Hello everyone, welcome to the Mercury Virtual. Hope you are doing good. Today I'm going to continue with your chapter number 6, that is memory hierarchy. In the yesterday's class I have started with the chapter and today I'm going to continue with the same chapter, that is memory hierarchy. So first of all, let's take a quick recap what we have covered in the last class. In the last class, we have covered about the memory hierarchy, for starting with the memory hierarchy. This is the objective. Study about the various types of memory. Means what are the types of memory that is available inside the computer system for storing the data in the computer. Then we have talked about the memory hierarchy. That is, what is memory hierarchy? Why we are using the memory hierarchy? What are the different types of memory that is used to store the programs and data? This is not all accumulated information is needed by the CPU at the same time. That is, the requirement of the information or the gathering of the information or the accumulation of the information is not needed by the CPU at the same time. But it may be possible that CPU requires the data at one time. At the same time, it does not require the data. So the all accumulated information is needed by the CPU, is not needed by the CPU at the same time. Therefore, it is more economical to use low-cost storage device to serve as the backup for storing the information. Then we have discussed about the types of memory, that is the main memory, auxiliary memory. The memory that is internal to the computer, that is known as the main memory. And the memory that is external, or that is used for backup the memory, that is known as the auxiliary memory or secondary memory. There is one more memory that is known as cache memory that lies between the CPU and the main memory. The main advantage of cache memory is that its speed is very high. That is, the access time is very high. Why access time is very high? Because it is too close to the CPU. That is why the access time is very high in respect to the computer. Then we have also discussed about the memory hierarchy diagram. This is the hierarchy diagram. First of all, there is the registers, then cache memory, main memory, magnetic tape, magnetic disk. So these are the different types of memory. One is registers, then cache memory, main memory, and at last secondary memory. That includes magnetic tape and magnetic disk. This is the diagram that shows the cache memory. The cache memory lies between the main memory and the CPU. This says CPU or the cache memory is very fast as compared to the main memory as well as the secondary memory. This is the diagram that shows various types of memory hierarchy in a pyramid format. We have discussed about this. Then we have discussed about the main memory in detail. That what is main memory? What are the types of main memory? So the main memory that is internal memory that contains most of the data or that stores most of the data. That is known as the main memory. There are two types of main memory. One is RAM and another one is ROM. So RAM is random access memory that is used for reading as well as writing the data. That consists of, or that is of two parts. One is static, another one is dynamic. Next one is your ROM, that is read-only memory. This is the RAM chip we have discussed. This is a comparison between the static RAM and dynamic RAM. This is the RAM that is volatile in nature. Why it is known as volatile in nature? Because it loses its contents once the power is off. That is, it loses the content when the power is switched off in the RAM. These are the types of RAM, that is static RAM and dynamic RAM. Then we have discussed about the comparison between the static and the dynamic. Then we have discussed about the ROM, that is used for permanently residing the memory or permanently store the data. The best example is that whenever we use the computer system, whenever we own the computer system, that there are so many screens, 3 or 4 screens that is available at the time of booting. That is stored in the ROM. Why it is stored in the ROM? Because that cannot be modified by the computer. These are the ROM types. We have discussed about the ROM chip also. These are the non-volatile memory, that is dynamic RAM, static RAM. Non-volatile memories are ROM, types of ROM, firmware. Then we also discuss about the auxiliary memory, that is your secondary memory, like floppy disk, hard disk, CD-ROM, pen drive. These are all known as backing up storage or the secondary memory or the auxiliary memory. These are the tips for secondary memory. This is the geometry that we have used. This is the data storage. These are the technology that is used for data storage. This is capacity of the disk we have discussed. These are the disk operations we have discussed. This is the access time. Then we have also discussed about the optical disk. That is, that contains 2 parts. One is CD-ROM, another one is DVD-ROM. So optical disk lies between the inner to the outer. That is, it starts with the inner part and goes to the outer part. That is an optical disk. And the types are CD-ROM and DVD-ROM. This is the diagram of the optical disk. This is a DVD. The full form of DVD is digital versatile disk. These are the tape storage systems that is used. One is magnetic reel, cartridge tape, digital audio tape, digital data storage, digital linear tape. Then cache memory. Again, it is a small memory, fast memory that lies between the main memory and the CPU. This says the cache is the fastest component in the memory hierarchy and approaches to the speed of CPU component. That is, it is very close to the CPU. It is the fastest memory that is used in the computer. Then we also discuss about the features of a CPU, that or features of cache memory. That is why we are using the cache memory. Then we have discussed about the hit ratio and the miss or the hit. Hit ratio is equals to hit divided by hit plus miss. Hit means suppose a data is available in the cache memory that is used by the CPU, that is known as the hit. And the miss is that when data is not available in the cache memory and the CPU approaches to the main memory, that is known as miss. So hit ratio equals to hit divided by hit plus miss. Then we will discuss how we can do the mapping from the main memory to the cache memory. The mapping is done by using the 3 techniques. There are 3 types of mapping. One is associative mapping, then direct mapping, and then set associative mapping. So there are 3 types of mapping in general: associative, direct, set associative. This is the cache memory diagram example. This is the memory address map that shows the pictorial representation of the assigned space for each chip in the system. We have discussed about the memory address map. This is the diagram, or this is the table for the memory address map. This is the associative mapping. We have discussed about this. This is the direct mapping. This is set associative mapping. We have discussed about this. This is the set associative mapping diagram. So that's all for yesterday's session. Now today I'm going to continue with your same topic, that is disk storage. How we can store the data and what are the methods that we perform on the stored data. That is the data that is stored on the disk. What are the operations, what are the methods, how we can access the data on the disk. So let's start. This says disks are warehouse storage devices. Why it is known as warehouse storage devices? Because it is used for storing the data. That's why it is used, or disks are used as a workhouse storage devices that holds an enormous amount of data on a large, on the order of hundreds of thousands of gigabytes. That is, it can store hundreds of thousands of gigabytes as opposed to hundreds of thousands of megabytes in RAM-based memory. That is, RAM stores hundred of megabytes or hundred of thousands of megabytes. But this can store hundred of thousands of gigabytes. However, it takes on the order of millisecond to read the information 100,000 times longer than the dynamic RAM and a million times longer than the static RAM. This says disk storage is very important concept when we use in the RAM. That is, it compares the disk as well as the RAM. RAM has a high capacity as compared to the, or disk has a high capacity as compared to the RAM, because RAM is internal to the memory and disk is the external part. That's why it has a high storage capacity as compared to the RAM. Then next one is a disk geometry. That is, what is the structure or what are the content of the disk. That is a disk geometry. So this says disks are constructed from the platters. That is how disks are constructed, by using the platters. Each platter consists of two sides. That is, each platter or each disk platter consists of the two sides surface that are coated with the magnetic recording material. A rotating spindle in the center of the platter spins the platter at a fixed rotational rate, typically between 5400 and 15,000 revolution per minute, that is RPM. So this is your single platter view, that is your spindle. These are the tracks, these are the surface. This is track K. For example, we have taken one track. This is one track, this is track K. There is a gap between the tracks, you can see. And these are the sectors. So there is a gap, there is a sector. There is a gap, there is a sector. So if I say disk contains various tracks and sectors, so this is true. That is, a disk stores the data in the form of tracks and the sectors. First of all, there is a track. In the track, there is a gap, and after the gap, there are multiple sectors. So a disk contains tracks as well as the sectors. This is the single platter view. This is the multi-platter view or the multiple platter view. This is one disk or the one platter. This is platter 1, this is platter 2, this is platter 0, and these are the multiple cylinders. There is one spindle that holds all the platters, all the surfaces. This says each surface consists of a collection of the concentric rings known as the tracks. So the rings are known as the tracks, and then each track is partitioned into a collection of sectors. Then each sector contains an equal amount of data bits, typically 512 bytes, encoded in the magnetic material on the sector. That is, first of all, the concentric rings are known as the tracks, and each track is consist of the multiple gaps, that is known as the sectors, or that are known as the sectors, and each sector contains multiple bits or multiple data bits. So if I say a disk geometry, that is first of all a disk is a combination of the tracks that are rings. Then that tracks are divided into sectors, and then sectors contains multiple bits to store the information. And sectors are represented or separated by the gap where there is no bit are stored. Now let's see with the help of PPTs. This is disk geometry, same concept. This is the same slide. That is, this consists of platters each with two surfaces. This is the surface 1, this is the surface 2. These are the two surfaces. Each surface consists of the concentric rings. These are the rings known as the tracks. Each track consists of sectors. So each track, this is the track, consists of sectors, as I told you, separated by the gaps. This is the multi-platter view. As I told you, there is a printer that holds cylinder, platter, surface. Then disk capacity. This is the disk capacity. That is, the maximum number of bits that can be recorded by the disk is known as the maximum capacity, or the simply capacity, or the disk capacity. That is, the maximum number of bits that is stored or that is recorded by the disk is known as the maximum capacity, capacity, or disk capacity. We can say anything. So disk capacity is determined or predicted by the following factors. One is recording density, that is bits in, then track density, then areal density. So these are the three forms or three criteria on the basis of which we can store the data, on the basis of which we can increase or decrease the capacity of the disk. That is recording, track, and areal density. This is your disk capacity. That is, capacity is given by the or calculated by the formula, that is number of bytes divided by sectors into average number of sectors divided by track into number of tracks divided by surface into number of surfaces divided by platter into number of platters divided by disk. For example, if we have a disk with 5 platters, so here there are 5 platters, the number of platters are 5. Then there are 5 and 2 bytes per sector. That is, this is the byte per sector. This is average number of sectors. Then 20,000 sectors per surface. Average of 300 sectors per. Then the capacity of the disk is. This is the formula. That is the number of bytes, that is equals to 5 and 2. This is number of bytes. Then average number of sectors. This is the average number of sectors, that is 300. This says na average number of sectors. Then number of tracks. These are the number of tracks. 20,000 tracks per surface. Then number of surfaces. This is the 2 surfaces. This is per surface. We have a disk with 5 platters. 20,000 tracks per sector. That is 2 surfaces. Then 5 platters. This is given 5 platters. If I multiply all these, this is 307200000000 bytes, that is equals to 30.72 gigabyte. This is the formula: number of bytes, average number of sectors, number of tracks, number of surfaces, number of platters. This is the important line, that the disk capacity is always measured in terms of the gigabytes. These are the disk dynamics, that is how we can move or how disk will be moved or spins. This is the disk spin at a fixed rotational rate. This is a fixed rotational rate. The read-write head is attached to the end of the arm. This is the read-write head, that is in circle, and flies over the disk surface on a thin cushion of air. By moving readily, the arm can position the read-write head over any track. So this can position on any track or head over the track. This is the read-write heads. These are the read-write heads. This is arm. This is the multi-platter or the multiple platter view. This is a single view. Now, next is your disk operation. That is, what are the operations or what type of operations we perform on the disk. So this is the disk capacity. That is, capacity equals to maximum number of bits that can be stored, as I told you. Vendors express capacity in terms of gigabyte, as I told you. Capacity is determined by the following factors, that is recording, track, area. Then next point says modern disk partition tracks into disjoint subsets that are known as recording zones. This is the computing, how we can compute. As I told you, number of bytes divided by sector, average number of sectors divided by track, multiplied by average number of tracks, number of surfaces, number of platters. Example is also given. This is what we have covered with the help of book. This is what we have covered with the multi-platter view. Now, next is your disk access time. The average time that is taken to reach on the or to access the target sector is approximately calculated by, that is, how to reach on a track and then reach on a sector, that is approximately calculated by the formula, that is T access equals to T average C, that is average number of time to taken on the C, then average number of time to rotate, then average number of time or average time taken to transfer. So this is the formula. Whenever we sum up average number of time for the seek operation and then average number of time for the rotation and then average number of time for the transfer, that is equals to the total time taken to access the disk. Then what is the seek time? How we can calculate the seek time? That is T average C, the time taken to position heads over the cylinder containing the target sector, that is known as the seek time. That is the average number of the time that is taken to reach on a particular cylinder, that is known as the seek time. The typical T average C equals to 9 microseconds. That is, this is the average requirement, or this is the average time that is used for going to the seek or the sector, that is known as the seek time. Then next is your rotational latency, that is the T average rotation. What is the time taken or what is the average time that is taken for the rotation? That is how disk will be rotated. What is the average time? That is the time taken or time waiting for the first bit of the target sector to pass under read-write head. This is the time average to take for the rotation, that is half into 1 divided by RPM into 60 seconds divided by 1 minute. Then next part is your transfer time, that is the T average transfer, that is the average time taken to transfer the disk. So this is the seek time, this is rotational latency, this is the transfer time, that is the time taken to read the bits in the target sector. This is the T average transfer, that is 1 divided by RPM into 1 divided by average number of sectors divided by track into 60 seconds divided by per minute. These are the formulas that is used to calculate the T average C, T average rotation, T average transfer. And then these are sum up to calculate the time taken to access the disk. This is the example. This is the rotational rate, that is 72 RPM, average number of seek time, then average number of sectors per track, that is the 400. This is the derived, that is T average rotation equals to half into 600 divided by 72 RPM into 1000, that is equals to the 4 microseconds. This is T average transfer, that is where rotation, that is half into 1 divided by RPM. This is half into 1 divided by or 1 divided by or 60 seconds divided by 1 minute. This is 60 seconds. This is 60 divided by 7200 because this is given 7200 RPM. Then divided by 1 meter or 1 minute, that is your 1000 microseconds per second. That is equals to the 4 microseconds. Then we have calculated the T average transfer, T excess, that is equals to the T average time taken, that is 9 ms, that is microsecond. This is given. We have calculated the transfer time, we have calculated the rotation time. Then sum up, this is equals to the excess time taken to access the disk values. Then logical disk blocks, what are the logical disk blocks? This says modern disk present a simple abstract view of the complex sector geometry, that is the set of available sectors is modeled as a sequence of bite-sized logical blocks, that is 0, 1, 2. Then next point says mapping between logical blocks and actual sectors, that is maintained by the hardware and firmware device known as the disk controller, that converts the request for the logical block to the triplets. Then next point says it allows controller to set aside spare cylindrical for each zone. This is the input-output bus. How we can transfer with the help of input-output devices, that is done by the input-output bus. That is, first of all, there is a CPU chip. This is a CPU chip. This is the bus interface that interacts with the register or ALU. This is the register file. This is the ALU. So this is the register file interacts with the ALU as well with the bus interface. This is the system bus. This is the memory bus. There is a mediator that is known as the input-output bridge that acts as a bridge between the computer and the CPU. This is your input-output bridge. This is the system bus. Then memory bus. This is your memory bus. Then main memory. This line or this bus is used for connection between the input-output bridge and the bus interface, and this gap or this line or this wire is used for input-output bridge and the main memory. This is input-output bridge that contains contains multiple slots. Input-output bus, that is expansion slots for other devices such as network adapters. This is the USB controller that contains mouse, keyboard. This is a graphics adapter that contains monitor. Then disk controller that contains disk part. These are the expansion slots for other devices such as network adapters. So this is the input-output bus that contains or that stores the data with the help of system bus, with the help of memory bus. This is the input-output bus that interacts with the input-output bridge. Then reading a disk sector, that is the CPU chip. This is the CPU chip, register file. The same scenario is taken, but there is one line that goes to the disk controller directly. There is a direct communication between the bus interface and the disk controller. This says CPU initiates a disk read by writing a command logical block number and the destination memory address to a port. That is how CPU initiates a discrete by writing a logical command block number and the destination memory address to the port that is associated with this controller. This is the next part that directly communicate with the main memory also. That disk is also communicate with the directly with the main memory. That is known as the DMA. That is direct memory access. So the disk controller reads the sector and performs a direct memory access time or direct memory access transfer into the main memory. Then next point says when the DMA transfers or transfer completes, the disk controller notifies the CPU with an interrupt that is asserts a special interrupt pin on the CPU. That is when the DMA, that is direct memory access, transfers completes or transfer the complete operation, then the disk controller notifies the CPU and issues an interrupt signal, that is issues an interrupt pin on the CPU. So that is your how it will communicate with the CPU chip directly, that is done by the interrupt or that notifies the interrupt. Then what is hard disk? These are the disk operations, that is read-write arm or read-write head connected to the actuator arm. There are three types of seek time, or there are three types of time that is used, or three components, that is seek time, rotational latency and transfer time, as we have discussed with the help of slides. This is the seek time, that the time taken to move the arm is known as the seek time. One is rotational latency, that is position over the track, that is known as the rotational latency. So if I say latency, that is the time taken to reach on the particular track, that is known as the latency time, and the seek time is the time taken to reach on a sector, that is your seek time. Then transfer time, that is the time taken to transfer the bit from one sector to the another sector. This is the same example as we have discussed. This is another example you have to do your own. Then logical disk blocks. This is an example. Then how to connect with the input-output devices. We have discussed with the help of PPTs. That is, there is a device. This is input-output devices such as graphic card, monitors, mouse or mice, keyboards and disk are connected to the CPU and the main memory using the input-output bus such as PCI or Intel's PCI, that is Peripheral Component Interconnect or PCI bus. Unlike the system bus and the memory bus, which are CPU specific, input-output buses such as PCI are designed to be independent of the underlying CPU. That is, if I am using the input-output devices or if I connect the CPU with the input-output devices, I may use the concept or I may use the connection, that is PCI, Peripheral Component Interconnect bus, that is used or designed to construct as an independent CPU. For example, PCs and Macs, that is personal computer and Macs, are both part of the PCI bus. This is which we have discussed with the help of slides. This is a USB controller. There is USB controller, that is a conduit. for the devices attached to the USB. This is the mouse, solid state disk, keyboard. There is a graphic card, that is an adapter. There is a host bus adapter, that is SCSI SATA. Additional devices such as network adapters can be attached to the input-output bus by plugging the adapter into the empty expansion slots on the motherboard. This is the disk controller. Then this is the CPU chip. Then how to access the data, we have also studied about this, how to access. There is a direct communication, direct interrupt between the disk and the register, that is reading a disk sector. This is directly reading a bus. This is says reading a disk sector, that is direct communication between the memory. This is direct communication between the bus interface. This is the DMA, as I told you, that is direct memory access. These are the multiple floaters value. These are the zones that is used. Now let's see slides. There is a next concept, that is your hard disk. So first of all, let's take 5 to 10 minutes break, then come back starting with the next topic, that is your hard disk. So first of all, let's take 5 to 10 minutes break. Now let's start with another topic or the next topic, that is your hard disk. This is hard disk. There is a low-level format that organizes both sides of each platter into the tracks and sector to determine where items should be stored on the disk. That is, whenever we say low-level formatting, that is both the sides are used and divided into tracks and the sectors to define where the item will be stored on the disk. Then next part is your partitioning, that is used to divide the hard disk into separate area known as the partition, and each partition is serves as a separate hard disk drive. Then high-level formatting, that defines the file allocation table for each partition, which is a table of information that is used to locate the file. So these are the three features, or these are the three tips, or these are the three characteristics that is available in the hard disk. That is, one is low-level formatting, that is low-level format, then partitioning, then high-level formatting. This is the storage system, that is your hard drives. Hard drives are of two types, that is SCSI and IDE. Then IDE drives was originally developed as an alternative to more expensive SCSI drive. So limitation of SCSI is it is very expensive in nature. Next point says modern versions known as the EIDE drive, that is enhanced IDE drives. Then it can support, means IDE drives can support up to 4 multi-gigabyte, multi means double gigabyte drive. If you want more drives or more devices, use the SCSI or USB. This is the low level formatting at the factory. Then what is low level formatting? That scans the disk for defects and set aside sectors with the defects so that they are not used for the data. That is formatting the disk for the defect and the sectors, and removing the defects so that they are not used for the data. Then IDE drive should never be low level formatted by the user or technician. That is, IDE drives always be a high level formatting or high level format drives. This is only high level format is necessary. Then how to install or installing IDE/EIDE drives. it supports two drives in a system. One is master and one is slaves. Set master and slave using jumpers. Then EIDE supports 4 drives because it is an enhanced version. So it supports two drives on each of two cables. One for one master and other are for slaves. And IDE and the EIDE drives both uses 40 pin ribbon. There is a ribbon that is of 40 pins that contains or aligned to the pin 1. Then next is your hard drive. This is the diagram of the hard drive, internal structure of the hard drive. That is how a hard disk works. This is the hard disk. Step 1, that is the circuit board controls the movement of the head actuator and a small motor. This is your step 1, that the circuit board. This is the circuit board that is used to control the movement of the head actuator and a small motor. Then step 2, a small motor spins the platter. That is, then it rotates the platter, or the motor spins the platter in the entire time the computer is running. So this motor is used to is used to rotate the pins. These are the pins that are used to rotate these platters or the circular path that spins entire the computer execution. Then this is the step 3. When software requests a disk access, the read-write heads moves to the FAT, that is file allocation table, to determine the current of or new location of the data. This is that it is moved to the FAT. Then fourth point is, this is the head actuator that actuates the head. This is the head actuator position the read-write head arms over the correct location on the platter to read or write the data. This is the actuator. This moves the data, or this moves the read-write arm to position the correct or to move the correct position. So these are the 4 steps that is available inside the hard disk. That is how hard disk works. Then what is a floppy? Floppy is coming in 2 sizes. One is 3.5 inch and another one is 5.25 inch. 3.5 inch holds 1.44 MB for high density. That is, the higher capacity is 1.44 MB, and 750 KB for the double density. One is high density, one is double density. A high density contains 1.44 MB and the double density contains 750 KB. Then it is connected with the 34 pin ribbon cable. Then 2 floppy drives possible, that is, it is possible to use 2 floppy drives. Then has twist in the cable to differentiate between the A drive from the B drive. So whenever we use 2 floppy drives, so it can differentiate by using the twist. Then what is SCSI? That is pronounced as the SCSI, Small Computer System Interface. So the full form is Small Computer System Interface. This says for a wide range of peripheral devices including hard disk, tape drive, optical drive, CD-ROM and disk array. That is, it is used for the peripheral devices that include hard disk, tape drives, optical drive, CD-ROM and the disk arrays. Next point says 8 devices can connect to a daisy chain. That is, 8 devices are used to connect to the daisy chain. Then this chain must be determined at both the ends. That is, this chain means that the chain that is used as a SCSI that must be terminated at both the ends. Each device or chain is assigned a unique ID, that is unique device ID number, that is determined by the jumper or the DIP switches. So there is a unique ID that is allocated to the different jumpers or DIP switches. Then installing and configuring SCSI, that is how to install and how to configure SCSI. That is, SCSI bus supports 8 devices. There are 8 SCSI IDs numbered from 0 to the 7. So SCSI can support maximum of the 8 devices and it can support the IDs from the 0 to the 7. ID 7 is always reserved for the SCSI host adapter. So there are 8 devices starting from 0 and ending with 7, and the ID7 is reserved for the adapter. That is, the last one is reserved always for the adapter. Then SCSI hard disk, if used as the boot drive, is assigned SCSI ID0. So the first page or the first drive is known as the ID0, that is used for the booting, and the last drive is used for the adapter, that is SCSI host adapter. If we are using both the IDE and the SCSI hard drive, IDE drive should be the boot drive. That is, IDE is the better option, that's why it is used as the boot drive. So there are two options, one is IDE and another one is SCSI. Now, what are the types of SCSI? There are three types of SCSI. One is SCSI 1, SCSI 2, SCSI 3. There are different capacities, different transfer rate, different connectors, different data buses that differentiate between the or among the different categories of SCSI. That is, SCSI 1 uses or use 5 MB transfer rate, that is Centronics 50 pins or DB25, and has 8 bits bus. SCSI 2 is also known as the SCSI fast wide, includes 16 bus or data bus, known as the wide SCSI, and twice as fast as the transfer rate. Then SCSI 3 includes Ultra SCSI, Wide Ultra SCSI, and the Ultra 2 SCSI that contains 16-bit bus up to the 80 MB transfer rate. These are the different transfer rates, different transfer memory, different pins that are differentiate between the different SCSI categories. Then next part is your, or the next storage device is your RAID, that is redundant array of independent disk. This category, this divides the category of disk drives that employ 2 or more drives in combination for the fault tolerance, that is error recovery. So this is the RAID, that is redundant array of independent disks, that divides the disk drives that employ 2 or more drives in combination for the fault tolerance, that is error recovery. There are 10 levels of RAID, that is there are 10 categories of the RAID. 3 on test will be, that is RAID 0, RAID 3, RAID 5. That is 3 that is used are RAID 0, RAID 3 and the RAID 5. So this is used as a storage device that stores the data as an independent disk on the independent disk. RAID 0, that is stripped disk without the priority. This is a disk that is without the priority, without any parity bit, not priority, this is a parity bit, that is known as the RAID 0. Then RAID 3, this is a parallel transfer with parity. RAID 0 is without the parity and the RAID 3 is with the parity. Next one is the RAID 5, that is data stripping with the parity. So RAID 3 and 5 are used with the parity and RAID 0 is without the parity. Then how data is organized on the disk, that is how data is stored on the disk. First of all, there are tracks, then sectors, then cylinders, then clusters. So first one is your tracks, that is the circular areas of the disk. So whenever we see the concentric rings that are known as the tracks, that is your circular areas of the disk. Then length of a track, one circumference of the disk over 1000 on a hard disk. Then data first returned to outermost track, that is mostly data is returned to the outermost track. Then sectors that divide the track sections, that means sectors are the division of the tracks only. Whenever we divide the tracks into multiple chunks, multiple parts, that are known as the sectors. On a floppy, 9 sectors exist. So example is the floppy, there are 9 sectors exist on the floppy. Then cylinders, that is logical grouping of the same track on each disk axis in a disk unit, that is logical grouping or the logical grouping of the same track on the each disk surface, that is your cylinders. Next is your clusters, that is groups of sectors used by the operating system. So whenever we combine the multiple sectors, that is known as the cluster. There are 64 64 sectors in one cluster. So there are 64 sectors in the one cluster. These are the tracks and the sectors. These are the tracks, that is concentric circles. These are the sectors, that is small arc of the track. It can store maximum of 512 bytes. Means each sector can store maximum of 512 bytes. Next part is your interleaving. That allows the read-write head to use the rotation of the disk to its advantage. One sector is written to and the disk shifts to the server sector down. That is interleaving. Then what is formatting? That is, there are two types of formatting, that is low level formatting and the high level formatting. Now, low level formatting is done at the factory, that builds the file allocation table, that is your FAT. Then this says physically scans the disk media for the defects. That low level formatting physically scans the disk media for the defects. Remember, FAT is always located at the track 0. As I told you, file allocation table is used for the bootstrap loader, is used for the booting. That's why it is stored at the track 0. Then next formatting is your high level formatting, that is automatically done during the installation of the operating system. So low level formatting is done manually and the high level formatting is done at the is done automatically during the installation of the operating system. Then operating system file systems, that is, these are the file systems that is used by the operating system, that is those using the FAT. Windows 3X uses virtual FAT, Windows 95 uses vFAT and the FAT32, Windows NT uses NTFS. So these are the file systems that are used by different operating systems. Then partitioning means dividing the tracks into different partitions so that they are converted into or they convert into the sector. That is known as the partitioning. That can says fdisk command is used. That is, whenever we say or whenever we want to do the partitioning of the disk, that is done by the fdisk. Then fdisk command is used. It divides hard drive into the logical subsections which are seen by the operating system as a separate hard disk. This says partitioning divides the hard disk or the hard drive into multiple or the logical subdivisions which are seen by the operating system as a separate hard drive, as a separate logical hard drives. Next point says hard drive partition into primary and the extended partitions. The primary partition boots the system and can have 4 primary partitions. So first of all, partitioning is done by the fdisk command. Then partitioning divides the hard disk into the logical subdivisions. Then hard disk divides the 4 partition or the 4 primary partition that is used for the booting the system. Extended can be up to 23 times on a disk. That is, we can extend or we can make the partition of 23. Then partitioning disk improves the disk efficiency through the reduced cluster size. Windows, that is your Windows operating system, Windows 3X and early version of Windows 95, a hard disk covers over 3 GB must be divided into small partitions. Then Windows 95 and Windows 98 can create a primary partition of up to 8 GB. Following partition, the first sector on the cylinder 0 is used for the master board record. As I told you, first is used for the master board record. Next is your disk compression, that is reducing the size so that it may be adjusted to form the multiple spaces. This is reduces the amount of space taken up by the files by substituting the codes for repeating patterns of data. That is, it reduces the amount of space so that it can be used for storing the data, for coding, for repeating patterns of the data. That is your disk compression. Next point says, to access the data on the compressed disk, must load disk compression utility into the RAM first. That this compression utility works between the OS and the disk controller. So disk compression is used between the operating system and the disk controller to intercept the request and compress or decompress the files. Then how to take the backup? Means suppose my hard disk is filled. So if I don't have a backup capacity or I don't have a backup capability, so my data is lost. So it is possible to take the backup, and the backup is done by using the three methods, or there are different types of backup methods. One is your archiver, that takes full backup. Suppose I've taken, I've stored 234 MBs of data in the hard disk. So that full backup is done by that backup technique that is known as the archiver. That is known as the archival, that is your full backup that contains everything from the hard disk. Then incremental backup, it contains only those files that have been modified since previous backup. That is, if I put the end node, or if I put the tag in the at some area, that is after that portion, then backup will be modified or backup will be stored. That is your incremental backup. Next, differential backup, that backup the data modified since last full backup. This is the next point. Copy backup, that is copy duplicate of the file, directory or the disk to the another disk. Now next is your CD-ROM. Next is your CD-ROM, that is compact disk read-only memory, that is your CD-ROM. Now let's see what is CD-ROM, what are the capacities, what are the tools available for the CD-ROM. CD-ROM have a capacity of 650 MB, that is, it can store maximum of 650 MB. The transfer rate or the transfer speed of around 24 into or 24x speed. This is CD is the slowest device on the PC. That is, it is one of the slowest device, and the full form is compact disk. Next point says, when installing to the IDE system, that must be configured as a slave part. That is, next is the WOM and EO. That is, CD-ROM I have a different versions, that is WOM, write once, read many times. Then this is a disk drive. There are multiple parts. As I told you, there is a spindle, there is a platter, there is a read write heads, there is a case, there is a controller, there is a data cache. That is external connection, IDE ATA or ATA, SCSI, USB. IDE is integrated digital equipment or environment, then ATA, then SCSI, USB. These are the controllers, these are the details, cache memory, case, this is the controller, data cache. Then price per megabyte of magnetic hard disk from 1981 to 2000. That is how price will increase or how price will decrease from 1981 to 2000. In 82, the price is 100 or 50. Then this is 86.20 MB is available at the 5 rupees, 10 rupees. This is 2000. This is 45. This is prices per MB, 52 per byte, 250 gigabyte, $1.25 per GB, 40 GB, Barracuda, then hot swap, GB Ultra. This is your hard disk geometry. That what is the geometry or what is the structure of the hard disk? One is known as the platters, that contains two-sided magnetic material. That is your platter, that contains 1 to 16 per drive, 3000 to 15,000 RPM. Then tracks. What are the tracks? That are the concentric rings that bits laid down serially, that is divided into the sector. Then tracks is divided into the multiple sectors. Then next part is your cylinders, that is the same track on each platter, arms move together. Then operations, what are the operations? One is your seek, to move the arm to the track, then read write, wait till sector arrives under the head. Then transfer the data. That is what is the operation, that is to transfer the data. This is your hard disk geometry. One is platters, one is tracks, one is cylinders, one is operation. Then how to move the hard disk or moving head disk mechanism. How to move? This is the arm assembly. This is one. This is read write head. This is the arm. This is platter, cylinder C, sector, track. This is the sector, internal part, shaded part. These are the tracks. This is the spindle. How it will rotate? This will rotate. This is the arm. This is the platter. Another platter. Another platter. This is manufactured in the clean room. Permanent airtight enclosure. That is your hard disk. Spindle motor integral with the shaft. Then flying heads. That is float over the moving surface. Velocity is greater than 100 meters per second. Then excess capacity, that sector remapping for the bad blocks. 20,000 to 100,000 hours mean time between the failures. Early days, that is it is used in the early days. Today its bandwidth is not high. Then see what are the seek operations. This is the seek time is approximately equals to k into distance. This is the road disk layout. This is what the disk looks like. Then how to format the disk. That is an important part. How to format. Write the all sector addresses. Then read and write back previous various pattern on the sector. That is text the sector and identify the bad blocks. Then what is a bad block? That any sector that is not reliably return the value, that is known as the bad block. So suppose I have 5 sectors. One sector does not return the value, but we cannot rely the value that is given by the sector. Then that sector on then that block is known as the bad block. This is a bad block management. That is how to manage the bad block. That is bad blocks are inevitable. That is part of the manufacturing process is less than 1%. Detected using the formatting. Occasionally blocks becomes bad during the operation. Manufacturers add extra tracks to all the disk. This is your bad sector handling, how to handle within the track. This is your spare sector, bad sector, replacement part that is replaced. Then 7, this is a 7. 7 is replaced by this part. This is a spare part, then 7 is replaced, 1 is missing. Then another, if there is another bad sector, that sector is replaced by the spare sector. A disk track with a bad sector. This is the bad sector A part. Substituting a spare for the bad sector. This is the substitution part. Then shifting all the sectors to bypass the bad one. That is shift 1, 1, 1 each part to the next sector. Next, logical versus physical sector address. That is, some sectors have a logical address and some sectors have a physical address. That is, some disk controller converts cylinder, track, sector addresses into the logical sector number. That is linear array, no gaps in addressing, bad blocks concealed by the controller. The reason is that backward compatibility with older PCs, limited number of bits in C, T and S fields. That is cylinder, track and sectors. Next, Disk drive performance. What is the performance of the disk drive? One is your seek time, that position the head over the cylinder, that ranges from 1 to the 25 microseconds. Then rotation latency, that is wait for the sector to rotate under the head. Then full rotation, that is 4 to 12 microseconds. Then latency averages, that is half of the rotation time. Then transfer rate, that is approximately 40 to 380 megabytes per second. Then transfer of 1 byte, that is seek time plus the latency time plus transfer equals to 6.04 microseconds. So these are the multiple disk drive performances issues. So one is seek time, rotational latency, transfer rate, transfer of 1 kilobyte. This is your disk reading strategies. That is, what are the strategies that is available for reading the disk? One is your read and cache a whole disk. Then start from the current head position. Then start with the requested sector. These are the different strategies that is available. There are none. The best one can do is collect together a sequence of contiguous sectors for writing them in a single sequence of disk actions, caching for later. That is, we can use the cache memory for the bad blocks. So that's all for today's session. Now let's see with the help of book. This is we have discussed about the DMA. These are the platters, surfaces, cylinders we have discussed. Anatomy of a commercial disk, that we have discussed about the geometry of the disk. Then solid state disk, next topic, that I will discuss in the tomorrow's class. That is, what is the solid state disk? That is an SSD. So that's all for today's session. Tomorrow I will discuss about this, that is your solid state disk. So let's take a quick recap what we have covered in the today's class. We have continued with the chapter 6, that is memory hierarchy. We have discussed about the disk geometry. What is disk geometry? How it will be used? These are the disk geometry on the multiple processor. Then disk capacity. What is the capacity of the disk? What is the formula used? How we can compute the disk capacity? What are the disk operations that is used on the disk? That is, what are the operations that is used on the disk? This is a multiprocessor or multiplatter view. Then we have also discussed about the disk access time, that is the time required to access from the content from the disk operations. Logical disk load, input output bus, reading a disk sector, we have discussed about this. Then we have discussed about the hard disk, storage system. What are the storage system that is available, like hard drive that are of two parts, SCSI and IDE. Then what is low level formatting, how to install the IDE and the EIDE drives. Then what is the hard disk, floppies, what is floppy, what are the sizes floppy, what is SCSI, how to install and configure the SCSI. Then what are the types of SCSI, that is SCSI 1, SCSI 2 and SCSI 3. Then what is the RAID, that is redundant array of independent disk. These are the categories of RAID, that is RAID 0, RAID 3, RAID 5. 0 is without the parity and 3 and 5 are with the parity. Then how data is organized on the disk. These are the tracks, and the sectors are portion that contains 512 bytes. Then we have discussed about the interleaving, formatting, like type of formatting, that low level formatting, high level formatting, partitioning, and the command that is used for partitioning is fdisk, that divides the drive into the two parts, logical subdivision, that is your logical hard drive and the physical hard drive. Then partitioning, disk compression, that is compressing the disk. Then how to take the backup by using the methods like archival, incremental, differential, copy backup. Then we have discussed about the CD-ROM that have a capacity of 650 MB. Then we have discussed about the disk drives. This is the splitter, platter, read-write head. This is the price of per GB. Then hard disk geometry, that is structure of the hard disk. These are the terms that we have discussed about the formatting, bad block, how we can rotate. This is the method how we can handle the bad sectors. This is the difference between the logical and physical address. Performance of the disk drive. These are the strategies for reading the content from the disk, for writing the disk. So that's all for today's session. Thank you so much everyone. Now in tomorrow's class I will discuss the solid state disk. So that's all for today's session.